Hi guys, I'm Aaron, and today what we're going to cover is two-line grooving can cycles, okay? External grooves, okay? This video won't be very long because most of the code is pretty simple. All we're going to do is kind of go over a type 2. If you're already familiar with a single line grooving can cycle, there's not a lot of variance between the two, but I am going to show you what the differences are, okay? So today what we're going to be doing is we're going to be using our code here to make the grooves on this part right here. So I've got two of these grooves. We're going to be doing this groove and this groove, okay? So the numbers we'll want to pay attention to is the lengths and then these diameters, okay? This print's kind of a little bit backwards because you'll have to take your overall length minus the distance from 0, because it is over here. So that together would be 1 inch 300 thousandths, okay? So that kind of tells us the distance between here and here. I'll let you guys figure that out a little bit later. However, all I want to do is just cover a little bit about how this works, okay? So we'll go back to our code and I'll kind of show you what we're doing. So the first thing we're going to do is we're going to position ourselves right there, okay? We're actually going to position the side of our tool right there, and I'll show you why that's important. So we'll keep this here. We'll switch back to our code. Okay, so first thing I'm going to do is I've got my, in parentheses, this is going to be my tool 2 grooving. We're going to be using a Siemens control for running this program. So I'll point out a couple variables that need to be correct in order for it to run properly on your simulation and on your machine. So up here at the top, you'll notice I have a T0202. Now on most machines you just type in T202 and it will index to tool 2 and pick up the offsets. However, I need that additional 0 for the Siemens control machine because it helps with the machine's logic in picking it up correctly. Okay, so with that said, I've got my tool called up. I've got my spindle cap here. Okay, now my spindle cap is the same thing as a G50, but on the Siemens control it's going to be a G92. Exact same thing, but just a different G code, okay? You'll run into that a lot on different style machines. Just something to get familiar with, all right? I've got my G96. I'm turning on my constant surface speed. I have moved in front of my part. Okay, I'm 1.5 inches above it. And then I'm gonna position myself, remember that clear plane that I was talking about? I'm gonna position myself in Z, 1 inch, 425 thousandths. But if you remember, I said the distance was only 1 inch 300 thousandths. So what gives, right? Why am I moving an additional 125 thousandths? The reason why is if I have an insert, see if I can draw this good enough. Okay, that'll be good enough. So if I touch off my tool on the left side or the face of my part, okay, if I move 1 inch 300 thousandths, that puts my tool right there. But you can obviously tell from the imagery here, I would actually start grooving into my threads. So I'm going to do 1 inch 300 thousandths plus the width of my tool, which in this case is 125 thousandths. Okay. Now the right side of my tool is lined up with the right side or the left side of my groove. Okay. That's why it's there. So let's go back to our code now that we have properly positioned my tool, and I'm actually a bit higher because I am above this surface. I'm at 1 inch 500 thousandths, which is 500 thousandths above that line. Okay, so we'll keep that on there, and then we will switch back. So what I have on here is I've moved to my correct position. Now I have in parentheses what everything means. Okay, so if you come down here, you'll notice that I have a 2-line can cycle for grooving, all right? So the first G75 that comes up has an R. All that line does is tell the machine the retract amount, okay? Retract per peck, because this is a grooving can cycle, it's gonna continue to go down into the groove. And every time it retracts, if we're just going straight in and straight out, it's going to retract by the full amount. But if we're going a pecking can cycle, okay, which is what we are doing, every time it goes down 100 thousandths, it retracts 50 thousandths. Okay, so something to remember. So the next line of code, this is pretty much just like a type 1 can cycle. In fact, almost the whole line is with some little variances. So what we'll talk about is the second line, which is our G75 again. So my X is going to be the finished diameter. And if you'll see here, I have 750 thousandths, and that is because this diameter finishes at 750 thousandths. Easy enough. Now my Z is going to be 1 inch 500 thousandths, okay? That is the furthest point in the Z negative. That's how far back I need that groove to go, okay? So with that said, let's kind of show you what we're talking about. The groove starts here, but it ends right there, okay? It only moves 75 thousandths, okay? So not very much. If you wanted to hand program it, it would be just fine, but these can cycles help if you have wider grooves, or if you don't want to hand program it, one line of code does the trick, okay? So all I did was I took my overall, okay, and then I subtracted that from it, which in this case is 1 inch 500 thousandths, okay? And that is what my Z is. That's as far back in Z as it goes. So we'll come back to our code. And with that said, I have a Q, a P, and an F. Okay, those are my final values. My Q is the groove step over. Okay, so if you'll notice, it says 1,000. Okay, so that's kind of weird, right? Well, in this machine, it thinks pulses. So one pulse is 1/10 of an inch. So that means if I need to move over 100 thousandths, I have to take 100 thousandths divided by 1 pulse equals 1,000, okay? And it doesn't matter, it's whatever step over you want. I'm using an 1/8 inch grooving tool, so I'm gonna move over about 80% of the tool. So that way my tool stays nice and rigid, but I'm not leaving any excess material behind me, okay? So the next thing I'm gonna do is I got the P. So remember I told you that I'm gonna peck so much and then I'll retract. Well, here's where that peck goes right here. Again, the P is in pulses. 1 pulse equals 1/10 of an inch. So if I want to peck 50 thousandths at a time, the P has to be a 500. And then of course I have my feed rate. So for grooving, you got to remember, we're putting a lot of downward pressure on a tool that's sticking out of a spindle. So if I get too aggressive, I'm going to risk the chance of actually pushing my tool out of the spindle. So I want to keep my feed rate simple. So I'm actually going close to a finishing feed rate, which is about 7. So 5 to 7 would be just fine. 12 to 15, like on the other roughing can cycles we do, might be a bit excessive. Just kind of depends on how big your machine is as well and what kind of support you have. So with that said, that can cycle's all done. I have successfully done that groove right here. I've successfully done this groove. So what happens now is, make sure I get rid of that. So what happens now is I'm going to position myself to do this groove. So if you'll notice, this is 1 inch 700 thousandths. So that means I need to be higher than 1 inch 700 thousandths before I move my tool over here. Okay, so I have to come up and then move over. Now again, I'm going to be going from here to there, okay? And what that difference is what my Z position will be, okay? So what that means is I've came up 1 inch 800 thousandths and I moved back 2 inches 925 thousandths, okay? Normally it'd just be 2 inches 800 thousandths, but in this case I have to add 125 thousandths for my tool. With that said, all I have to do is type in my G75 again, and then it will do that groove at that location right there. So with that said, I go back to my part, and I can see, let's go back to it, there it goes. So I've done my first groove and my second groove. So using that for my 2-line can cycle for grooving, that's all you have to do. Kind of makes it really easy, okay? And remember, G75s also work if you're parting off a tool, if you want to just take small pecks at a time so that that chip can break off the tool or break off the part. All right, with that said, if you guys have any more questions, give me a shout. Again, my name's Aaron Rupp. Thank you for watching.